So I put in grades for the project, and if you did it, you probably did really, really well. If you didn't do it, you're probably not doing well right now in this class. Get it done. Super, super easy. If I can help you, then just let me know. Those of you that did it, I think that once you actually put in the work, it was relatively simple to get it all done. So just get that done in case you have not yet. I know we're learning a lot of new things, and I know that it's more like traditional math class than it was last semester. That's statistics. That's what it is. I just want to give you those basics that if you do end up taking like an intro stats class ever after this, you've got a decent background. Some good like stuff to start. Like even if you don't pick up on everything, you've got a decent background. And so chapter 1 was just kind of looking at like different ways of representing some stuff no matter what the data is. What I want to start looking at now is looking at some things that are a little bit more standard in the way that they're organized. And so I've got stuff that's going to be today and tomorrow. So folks at home, obviously you don't have copies of this yet. So you can either like look at the notes that I put on there and like print them and redo them, or just like put them in your notes and then we can fill them out when you get here. We're only going to do the first page front and back. So this is lesson 2, unit 2, lesson number 1, but it's going to take both today and tomorrow to get done. But what I think would be helpful, however you feel good about like means and medians and like plugging stuff into the calculator, either take out a calculator or be able to jump here, take one of these, or jump into like Desmos or like go to Google Sheets or something so that we can calculate this stuff quickly. I don't care how you do it. As long as you've got a place to do it, I'm good. Your phone's calculator, you have to like do it all out. Like you have to like to find the average, you gotta like add them all up and then press enter and divide by how many. Like you actually have to do the calculations. Google Sheets we just type in a formula and we're good to go. So eventually I'll probably just jump into like a blank one, like nothing you have to share with me. I just care about you getting to the answer. That's the most important part. So, all right. So what I thought would be helpful to figure. Oh my goodness. Get out of here. You go down there. What I thought might be helpful is to kind of give us just like instead of like a whole bunch of different problems to consider, like let's look at just one simple idea. And see if we can wrap our heads around how it would be best to make a good decision. And whether you're sports interested or not, that kind of will play to your advantage maybe. But like imagine this setup, okay? You've got 2 different running backs. Season has played itself out already, and you are ready for round 1. Now, you have to pick a starting running back. Now, if all we had to go on was the performance of that running back throughout the season, and we're not really considering leadership, work ethic, how he's done in the classroom, whatever the case is, if these were just the yards that he gained over the first 10 games, our 2 running backs, let's say they had everything else is equal, right? Equal playing time, equal size, equal everything. If all we had were these 2, let's see if we can pick the right choice, the best choice. All right, so here's yardage for each of those first 10 regular season games. So running back A versus running back B. And it's sitting right there on that piece of paper too, so you can always look it up right there. But 25, 86, 142, 101, 41, and so on. 98, 102, 105, 92, 108, like that, okay? And what I want to do to help us kind of see this, and this is actually, we're going to build off something we did last time. There's something called a back-to-back stem and leaf. And I just want to build that one with you. So we're going to do running back A over here on the left and running back B over here on the right. And it's actually kind of nice to see like 2 stem and leaves at the same time. So here, take this. 2 stem and leaves at the same time, back to back. All right. So we got these 2 running backs, and we're trying to figure out which one is the best. And so if we could just write out how they've done for the first 10 games, it might help us kind of figure out what's been going on. And so, all right, so let's do the running back A on the left. And I'm just going to go through. I'm just going to drop in. So, like, here's my stem. So, like, all my 10s, 20s, 30s, 40s, 50s. There's my 100s, 110s, 120s. And I'm just going to drop that last digit in the box. But here's how we're going to do it. This stem is going to go out this way. This stem is going to go out that way with that leaf. So first one, 25. Okay, so go to the 2, and then next to that, you actually put the 5 like right next to it. I know it's kind of weird because it kind of reads like 52. But remember, it's back to back, so numbers going this way. Okay, cool. And then 86. So there's a 6 right there. Come on, you. Why don't you like me today? 86. There we go. 142. So there's a 2 right there. 101. So 101 next to the 10. 41. It's kind of all over the place. 75. The next to the 7. Put a 5. And then 114. So 1, 1. Okay, so next to the 11, we'll put a 4. So that's 114. 58. Looks like 1 in every box. It's crazy. 99. And then 159. Whew. Okay, so there's running back A. Initial first impressions about what this guy can do? Yeah. He can get like he had a 159 and a 142 game, right? But he also had a 25 and a 41.
Is this yards or speed?
This is yards.
Oh, in the entire game. Okay.
Yeah, so this is a full game. So these are 10 different games. Yeah, that's not like per carry. That's per game. So 10 different games, 10 different yardage total. All right, let's do the same thing with running back B. Just going, now we'll just go to the right. So 98. All right, so next to the 9, we'll put an 8. So the first number is the inside. Second number, that last number. All right, 102. Now, for the first time, now we have a 105. So in that same row with the 10, it says 1, 0. Now I got to come to this kind of like that second box over there for 5. Again, 92, right? I already had a 98, so I got to come over here. Geez, another 100 and something. So 108. And since it's not like in order, I don't really care if it ends up in order once it's inside. Like if there's 104 somewhere, fine, I'll just put a 4 over here or something. 87. Now 9D. All right, so just a 0. That's fine. That's okay. It doesn't matter what order it's in. 95, so another one for in the 90s. 110, so a 0 next to that 11, and then 130. Now, eventually tomorrow, you're going to upload all of this work, pages 1, 2, 3, and 4. So take a second and make sure you have this written down, because that's going to be part of what I'm going to check tomorrow. So I'll give you a second to get caught up. But impressions about running back B compared to running back, or just on his own, or compared to running back A.
He's like a lot more consistent.
Okay. So although he didn't like 140s or 150s, he didn't have any of those big games. He also didn't have any duds either, right? He didn't have those games in the 20s, 30s, 40s, or even the 50s. Only 80s, 90s, 100s, and 110. All right, cool. All right, so what I'm going to do to make my life super easy, to calculate the mean and the median, so I'm just going to jump into Google Sheets and make this super, super fast. I'm going to have you guys actually help me out. I don't care where I go. I'm just going to put a new sheet somewhere. Running back A, running back B. Nikki, read off the numbers for A.
25 is this one, and then 41, 58, 75, 86, 99, 114, 142, 159.
Okay, and then B.
B is 87, 98, 92, 90, 95, and then 102, 105, 108, and then 110 and 113.
There was one more. Did we miss one? I think there were 10 for both of them. 25. We're missing something. 25, 86, 142, 101. That's what it is. 101. There we go. Sweet. Now, super, super easy. What was the first one they wanted? Mean? Okay, look at that. Average. They even suggested it. Average of those? Sure. Enter. Boom. 90. So this is my mean, and this is going to be my median. And I can just take this blue square in the bottom corner, drag it over. There's the mean for that one. I can click on it just to make sure, yeah, that looks good. There's my average. And then same thing with this one, equals median. What is it? A2 through A12? Oh, no, through A11, because that one was my mean. Boom. There we go. That was easy. I can't mess up the calculations if I let Google Sheets do all the work. So in that spot, I'm just going to leave it up here just for a second. That was so easy. All I have to do is type in a quick formula, and it does all of the work. I don't have to worry about, like, I have to add them all up, press enter, and then count them up and divide by 10. Or, like, line them up in order, and then I have to, like, chop them off at the ends to find the median. My mean for my first one is 90. So now I'm back to here. Now I can zoom out a little bit. The mean for running back A was 90. The median was 92.5. I just dropped it somewhere. 100 and 100. Nice. Okay, cool. 100. 100. And so what do you choose? Who do you take? If you had to pick, based on both that back-to-back stem and leaf, and now just some really quick measures of central tendency, the middles, averages and medians, great middles. Who do you take? B, of course. Now, is it just because of the median being higher? Not for me. Consistency is huge, right? And that's what we're trying to talk about when we talk about standard deviation. It's a mathematical fancy way of saying how consistent are you. It's a measure of consistency. That's all it really is. To try to figure out, all right, is the data like super spread out or is it pretty close together? And sometimes it can be really useful to know what that standard deviation is, because drawing a back-to-back stem and leaf, like that kind of took a while, right? And we only had 10 numbers for each person. How many points did you guys, like how much data did you guys collect for the project? 30, right? I don't want to do this 60 times just to compare the two if I had like 2 sets of data. And so although like the mean and median is really nice to have, I think what could like take out us having to do that stem and leaf the long way is to get a standard deviation for each player, okay? And so that is what we're going to be talking about to get things started here in Unit 2. Standard deviation tells us how spread out stuff is. That's all it is, okay? Now, it's a little complicated in the formula, and we're going to do it out the long way just so we have a little bit of appreciation for what Google Sheets can do for us. And they use this letter right here. Okay, it looks like this. That's not good. More like there's no, okay, that's the lowercase sigma in Greek. Okay, and they use S for spread. That's why they say. Okay. So the larger this number, whatever we get, it's going to be some number over here. Okay, the bigger that number is, the more spread out. The smaller the number, the more consistent all your data is. So like running back A is going to have a bigger standard deviation because his numbers are all over the place. Running back B is going to have a much smaller standard deviation. If your standard deviation is literally 0, that means all of your numbers are exactly the same. That's all it means, because there's no spread at all. How many yards did he get? 90, 90, 90, 90, 90, 90, 90, 90. Standard deviation, 0. 90, 90, 90, 90, 90, 90, 91. Super, super, super tiny, like really, really small standard deviation. Okay? Now, the formulas that happen in the background that we're going to actually work out today so you can see them and appreciate them and know that once we hopefully like do it today, tomorrow, we'll never have to do it again. They're kind of complicated. Like look down at your paper. Look at those right there. That is what's going to happen when we type in equals standard deviation in Google Sheets and let it do all the work for us. Okay, but I want to tell you what all of these things are. Okay, variance is S squared, standard deviation. And because I can't really type a sigma on paper, we just use S sometimes to make it easier. Okay, standard deviation is just the square root of all that. Okay. Now, what I think is going to be helpful for you to write down is just to kind of like mark up these formulas so you know what we've got. Now, I'm only going to mark them up once, okay? Because you only really need to see it once because the only difference is the square root, okay? N is how many you've got. It is your count. It's the number. Like I've got 10 games that I've got. I've got 30 data points. I collected data from 25 restaurants. That number, the count, how many? Okay. But look, it's n minus 1. So we're going to just take one away. Okay, that actually takes out some of the error in our calculations. Okay. Now, this is going to be multiplied by some stuff. Now, you don't have all this stuff like perfectly understood today the first time, but I just want to introduce you to some of these things. Okay? That lowercase looking sigma thing, right? That meant standard deviation. This weird looking E right there, that is actually an uppercase sigma, right? Because Greek letters, just like English, has upper and lowercase, okay? That is the uppercase Greek letter sigma. And what it means is the sum. In other words, add up some stuff and let's see what we get. Okay? This X with the little I right there, those are going to be all of your individual points. You're going to have the first one, the second one, the third one, the fourth one, right? I had his first game, his second game, his third game, his fourth game. These are going to all be your individual points, individual numbers, your individual data points. And they put that little I there just for that individual, okay? Because it's going to be like the first one. So it's going to be like X sub 1, and X sub 2, and X sub 3, and X sub 4, and we're going to add them all up eventually. But what we're going to do inside here is we're going to take all of those numbers and we're going to subtract something from it first. So your individual numbers are going to go there, and from every single one of those, and you're going to see this process play out today, we're going to subtract the average. We're going to subtract the mean. And we can say that out loud as X bar, if you want. Because it's got a little bar on top. Little whatever. But that's just the average. Look what we're going to do. We're going to take each point. We're going to subtract the mean. Then we're going to square it. Then we're going to add them all and see what we get. Sigma, we're going to add them all. What are we going to add? We're going to add all of this. Take each one, subtract the mean, square it. See what we get? Add them all up. And then we're going to multiply that by 1 over n minus 1. And then we're going to take the square root. Doesn't that sound painful in terms of how much math we have to do? That's why we're only going to do it a couple times just so you can see what, why this works. But this is the statistics that happens in the background. that happens when you type in equals and then some formula in Google Sheets. There's a lot of stuff that is happening in the background that we, like people way, way smarter than me, figured out a long, long time ago, and now we can just stand on their shoulders and let them do all the work for us. Okay, but I want you to kind of get that feeling of what it's like to work through. So go ahead, turn to the next page. And I'm going to help you work through these so you can see what it's like. And we're just going to do running back A first. Now, remember what we needed, right? We needed how many there were, the count, right? That was N. We needed the average. And then we just needed to do some math with those numbers, okay? And so, number one, count the number of values in each data set. Okay, I think it was 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and N is 10. That's just how many there are. What was the average for that first one? 92 and a half. 92.5. I like it. Now, here's where the calculator is going to have to do all of this work for us. And so I'm going to rely on somebody that wants to just knock some of these things out in their calculator. What we're going to have to do is subtract your number and the mean. We're going to do 25 minus 92.5. We're going to do 41 minus 92.5. We're going to do 58 minus 92, all the way down. And we're going to see what we get. I'm going to stop writing it so you get the sense. I don't have to keep writing it over and over again. To just take the number, subtract. And so you guys have calculators. Actually, I'm going to make this easier. Watch this. Here, I'm going to put, you don't have to write this, but I'm going to put numbers and items. You want to watch this? So, to kind of get you guys into the mode, Kaylin, you're the one with 25. Patrick, do 41. Maddie, do 58. Jason, 75. Pete, 86. Xander, 99. Chandler, 101. Tyson, 114. Nikki, 142. I'll do the last one, 159. Take your number, subtract the mean. Even with the negatives, I got to know what it is. I'm going to erase that. I need some space. But that's what I'm going to do. Galen, 25. Negative 67.5. Okay, so I'm going to erase it because I don't think I need to write it. Negative 67.5. Patrick, 41. Negative 51.5. Matt? Negative 34.5. Cool. Jason, do you have 75? No. Xander, hook him up. Pete, what do you got? You got 86, right? Yeah. What do you get? Negative 6.5. Chandler, 99. What was 99 minus 92 and a half? Oh, you did 101? Yeah. Oh, Xander, you 99 then? Yeah. Oh, okay. 6 and a half. My bad. Chandler, what's 101? 8.5. Tyson, 114. 21.5. Nikki? 49.5. Xander, did you help out? Jay? Yeah, 17.5. Negative 17 and a half. Okay. And then 159. Somebody help me out. Nikki, you're right there. 159 minus 92 and a half. 66.5? Okay. Now, take a second, jot those down. Now, take take it from your row and square it. multiply it by itself. So you're going to want to take whatever your number is. So again, Kaylin, you got the 25, Patrick the 41, Maddie the 58, Jason the 75. Just use your phone, it's fine. Pete 86, Xander 99, Chandler 101, Tyson 114. The number next to that, take that number and square it. They're all going to end up being positive, but if you forget to put in parentheses, it's going to spit out the negative. But we're squaring numbers, so they always have to end up positive. Ken, what do you got? 4,556. Point what? 25? Okay. Basher? 2,652. Okay. Ready? 1,190.25? Oh my goodness. Okay, I'll let you finish. Pete, what do you got? 42.25. I bet you're the same, right, Xander? Because you got the same number.
Yeah.
Cool. 42.25. Chandler? 8.5 squared. 8.5 times 8.5. Chandler, go first. What'd you say? Okay. Xander, go ahead. 306. There's so many numbers. Tyson, 21.5 squared. 400 something. 21.5 times 21.5. 462.25. Niggy.
This varies of 49.5?
No, you gotta square it. Go the other way. Multiply it by itself.
Oh, so
49.5 times 49.5 is like 600 something.
yeah. I got 2,400. Wait, 40.
Oh no, you're right. You're right. 49.5.
2,450.25.
450.25. And then Nikki, help me out with the last one, 66.5.
4,422.25.
4,422.25. Yikes. Okay. Ugh. All right. So we took each number, subtracted it from the mean, or we took the mean and subtracted it from the number. See what we got. We squared them all to make everything positive. Because look, we're eventually going to take a square root. Now we have to add all of those together. Every single number now has to be, like all of my blue numbers, all have to get added together. Oh my God, it's going to work, right? That's why we're not going to do this very often. I just want to show you how crazy this can be. All right, I'm going to look at my phone. I'm going to do all the punching numbers in. I'm going to give you guys a break because you guys just punch a bunch of numbers in. Let's see if we can do it. All right. 4,556.25 plus 2,652.25 plus 1,190.25 plus 306.25 plus 42.25 plus 42.25 again plus 72.25 plus 462.25 plus, oh my goodness, all that plus all this equals 16,196.5. 16,196.5. And now to the variance of that is right below. What it says in that spot is you just take that number and you divide by n minus 1. So whatever n was, we just got to take one away from it because that kind of takes out the error in the problem. So I'm going to take that, I'm going to divide not by 10, I'm going to divide by 9. Okay, so my variance, which is right at the bottom, I'm just going to scoot over here so I can keep this work up. That S squared. I don't even know if they wrote S squared. Do we write it? No, it just says variance right there. Okay. 1799, and I'm just going to round to 0.6. That's your variance. What is that? Just some statistical calculation. Okay, it tells us how different all of our numbers are. But to make it a little bit easier, 16196.5. To make it even easier, talk about standard deviation, we just take the square root of it. So in the spot right below that, it says number 3, find the standard deviation. All I have to do is take that number and take the square root of that. So equals, I got to turn my phone sideways to do it. I'm going to take the square root of that. So standard deviation, which is S, or even better, that lowercase sigma, 42 point. There's my standard deviation. Now, that number makes a whole lot more sense than the 1700. And here's what that number means. Basically, you can expect that if this guy has an average of 92.5, you can expect him to run anywhere between 42.4 less than that. So like 50 yards, to 42.4 more than that. So his like expected range is going to be probably between like 50 and 135. And that's what's really nice about like that sigma compared to the S squared, is like it gives me a sense for like where is he probably, what's he probably going to do? And I can expect, and we'll talk about it, I don't know if it's going to happen this week or next week, but like how probable is he actually going to be? So if we only have these 10 games to go on, we can actually say with some confidence that like 95% of the time, or 98% of the time, or 99.7% of the time, he's going to fall within these numbers. And that statistical probability is so nice to be able to say, okay, well, if that's what he's going to do, well, let's compare him to running back B and get a decent range for him as well. All right, so let's knock this out. Now that we've got the idea, we should be able to knock this one out pretty quickly. I'm going to split this here so we don't lose track of what we got. Let's do the same thing for him. If we can get a standard deviation, we'll be good to go. So again, we had 10 pieces of data. The average from him was 100, right? We did all that work already, so that was nice. Now this is going to be easier because I don't have to worry about decimals and stuff. I just have to subtract them and then we'll square them. So I'll do the first column and then I'll just have you squared. So let's rock the first column together. So I'm just going to subtract 100 from all these. So negative 13, negative 10, negative 8, negative 5, negative 2, 2, 3, 8, and 13. Super. 100. All I have to do is see how far away it was from home. Oh, yeah, that looks good. Take a second, jot that down. And look, we had like numbers like 67 and 51 and 34, 49, 66. We had such big numbers when we looked at the differences. Now my biggest difference is only 13 one way or the other, right? That was the consistency of the fall. All right, now we got to square them. Luckily, the numbers are small enough. I know these perfect squares. 169, 100, 64, 25, 4, 4, 9, 64, 100, 160. All I'm doing is squaring those numbers. We already went through the process. I put you through the ringer on that. I'll do some hard work for you. They're almost all the same, too. The only ones that are different, the -2. Oh, no, the -5 and the 3. Otherwise, it's like almost exactly broken up. Yeah.
Why is 105 3?
105. I don't know. It's not. Thank you. You're the man. I knew something was wrong. See? Nobody's perfect. 5 squared, 25. +1, Xander, for the day for catching a mistake. I'm going to give you an extra point on this homework, just for that. There you go. Boom. No, that's good. No, I want you to catch my mistakes. I make mistakes all the time. I need you to help me out. If I pretend to be perfect, this is not going to work. I'm so far from perfect. You guys have no idea. All right, let's add them up. Let's see what we get. 169 plus 100 plus 64 plus 25 plus 4 plus 4 plus 25 plus 64 plus 100 plus 169, 724. That's the sum. And look at that difference already. I mean, we haven't even looked at variance, let alone standard deviation. All I've done is I've taken the squares of the differences in the means, squared them, difference, subtraction, means, less, subtraction, less. What was in the 16,000s? This one's not even 1,000. Now, what I got to do from there, though, is I have to divide by n minus 1 to get the variance. So that's s squared. So I got to, all right, press equals, divide by 9, not 10, but 9. I'm just going to round 80.4. It's like 80.4444444. 80.4. And then take the square root of that. Standard deviation. So I'm going to press equals. Turn my phone sideways. So get the square root. To the power of 1/2. That's the square root power of 1/2 equals rounded. A standard deviation of 42 versus a standard deviation of 9? Are you kidding me? How much more consistent that guy is. I mean, we knew it from the beginning just by looking at the numbers, but now the stats can back that up. And that's what a lot of sports is moving to, this whole StatCast era of you can like quantify every single aspect of everything. Now we've got a number that can tell us what consistency is, right? Standard, the word standard, and then deviation to be different, right? So it's right there, right in the way that they described what we're actually doing by picking some words that make a whole lot of sense. Standard, deviation. What can I expect the difference to be from day to day? A standard deviation of 9 versus a standard deviation of 42.5, right? I mean, sure, this guy knocked out 159 and 142, but I want the guy that's going to be consistent. And we can use standard deviation across kind of all sorts of different sets of data to be able to kind of figure out, okay, how spread out versus how close together for all these numbers. So at the bottom there, go ahead. Take a sentence or two and write out which player will you choose to start for the playoffs tomorrow in whatever words you want to say. All right, so we ended up with one, 7, 6. Decimals did not do us any favors there for sure, but it is what it is. Google Sheets can do all that work for us, which is really nice. 80.4 and then 9. Here we go. Anybody picking player A? Probably not. Now, I don't think it's necessarily a wrong choice. Like, sometimes you got to take chances, right? What if he did drop a 200-yard game? He could do it. He's got the ability to do it. But are the chances of him doing it pretty likely? Probably not. And that's what I want to go on. I want to give myself a good chance to get the kind of outcome that I want. And sports is just one of like 1,000 different ways to look at this kind of stuff. But that's the idea. Got it? Sweet. That's standard deviation. That's all we have to do. And we're going to do it the long way only 2 more times. We've already done it twice. And I have to do it 2 more times. Once on that 3rd page, once on the back page. That is going to be your work for tomorrow. It's just those last 2 pages. Now, we'll do them tomorrow. So you can wait until then, and we'll do them together. Or you can just knock them out. Okay? Obviously, you'll need the calculator to do it, so you can add them up, find the mean. Like I did the mean, like right through Google Sheets. Obviously, it's just add them up, see what you get, and then divide by however many there are. But the process kind of walks you through it right there of what you need to do. Right? Count how many you got, figure out your average, do the subtraction, square it, add them up. Calculating the variance is divide by, and -1, divide by 1 less, and then take the square. It's kind of a long process, but simple if the calculator works for you, or if you can use Google Sheets to help you out. So if you want to start knocking this out for tomorrow, you got less work you have to do tomorrow, or you can just wait and we'll do it tomorrow. I will probably like recap practice problem number 1 with you, and then I will have you try the back one on your own. So I'm not going to work through that last one with you. I want to see if you can do it. But we will definitely work through that second one. So if you are good, if that was enough brain power for one class, then just chill. We got like 5 minutes. Folks at home, you guys are good to go. You can take off. I will catch you tomorrow in class. Bring this with you. Oh, you don't have it, but bring your work with you, and you'll have some time to copy stuff down if you need to. Okay, so I'll have copies for you, so you don't have to print them out. I will see you guys tomorrow.
Hey, Mr. Rosie.